this video, we will see what is solubility and what is solubility product. And of course, what is the relation between solubility and solubility product. So students, you know that every solid substance has a definite solubility in a given solvent. And the solubility goes on increasing as the temperature increases. You know about Henry's law that there is an effect of pressure also on the solubility of gas. Here, in this particular concept, we will be considering the sparingly soluble salts. Now, what are sparingly soluble salts? Sparingly soluble salts are those which have a very less solubility in water or the solvent. Very less solubility means what? Hardly they get dissolved in the given solvent. When we are talking about solubility, you know that like goes in like. Means what? Ionic compounds, most of the ionic compounds, they are soluble in water or the polar solvents. Now why they are soluble? Because the solute to solvent interactions, they are very strong. Similarly, the covalent solids, they are soluble in non-polar solvents, but there they have the weak interactions, that is van der Waals interaction. So solubility of any substance in given volume of the substance, it will give me the solubility or how much concentration of the substance is present in the given volume of the solvent, that is solubility. So I can say that solubility is the amount. So solubility is denoted by small s. It is the amount of substance, I can call it as a solute, the amount of solute present in given volume of the solution. So what will be the unit for this? It will be mole per dm³. In short, it is same as molarity. What is the concentration of the substance in the given volume will give me solubility. Now what is solubility product? To understand that, let us go through the derivation. Here I have considered a sparingly soluble salt, that is Ba. The salt is first in its solid state. Then I will dissolve this in a suitable solvent. So I will write here aqueous and then it will give me the corresponding ions. Applying law of mass action to this equation, what I will get is K is equal to B plus A minus upon dA. Now as I said that it is a sparingly soluble salt which hardly goes in the solvent. So what will be the concentration? This will nearly remain constant. So what you will get? B plus A minus upon constant. I will take this constant to this side. So K into constant is B plus and A minus, right? Constant into a constant will give me a new constant. So what will be that? As we are studying solubility product, so what I will give is K solubility product is equal to the active mass of the two ionic substances. What is there in the solution? So this is what is solubility product. How I can define the solubility product? First thing which is very important, I have to take a saturated solution. Second very important thing is we are considering a sparingly soluble salt. Right, students? Next very important statement what I made, that solubility increases with increase in temperature. So the third factor is that the temperature must remain constant. Now we will create the definition for solubility product. Solubility product can be defined as, if you see the particular terms here, we call this as the active masses or the molar concentrations. If you see what is the sign here is multiplication. So what we have here is the product. Right? So in a saturated solution of sparingly soluble salt, the product of ionic concentrations is constant at a constant temperature. Now immediately what the question is, if the solute gives some raised power here, say for example I write here M plus and N minus, we call them as raised powers, which are the number of moles as they appeared in the balanced equation. So how I will write this? If I say that the salt is, say for example, AM and Bm and Ay. Then how I will write that? I will put some charges, or I will write here M and I will write here Y. So what this will be raised to here, student? This will be raised to M and this will be raised to Y. So how I will define now solubility product? So let us write down how I will define it. So for this solubility product of how I will define in a saturated solution of a sparingly soluble salt the product of ionic concentrations raised to their stoichiometric coefficients or raised to their powers is constant at constant temperature. So this is how I will define solubility product. Right, students? Now let us see what is the relationship between solubility and solubility product. So let us continue this. Now instead AB, now I will take the proper coefficients for the two and then we will see the relation. So you have to consider 1 mole of a sparingly soluble salt. So what type of salt I will take is same, that is Am and By, and we will do the derivation. So let us consider a sparingly soluble salt. That is, what type of salt I will take is Bx and Ay, and I will dissolve this in water. So what I will get, Bx, Ay, aqueous will give me B. Now how to form this particular with raised powers? For that I am taking one of the examples, say for example Al2O3. Now how to split this, student? So I will make a marking here in this way. I will write Al here. Whatever is on the opposite side here, that I will mark it as a charge. For this, I will write O here. What is on the opposite side, I will mark it as a charge here. Now to balance the number of moles, whatever is below it, I will write here. Whatever is here, I will write here. So this is how you will form the ions. Let us take one more example. I can have, say for example, we can take one more example like Al2SO4 thrice. Actual example, how I will split this now? I will split this in this way. I will write Al on this side. For this I will write Al on this side. I will write SO4 on this side. This particular thing I will give to this. So it will be 2 minus. This 3 I will give to this. So it will become 3 plus. This as it is here and this as it is for this. So this is how you form the ions. So let us try for this. So I will write B. Whatever is opposite, I will put that as a charge. So it will become Y plus. And this I will write here as A. Whatever is opposite, I will mark it here minus. Then this will be X as it is and Y here. So this is how I will split the salt. I hope this is simplified how to write this. Now let us continue. So this is a salt, that is BXAY. I have dissolved that in water. So next let us write, below this you have to write KSP. Below this you have to write is equal to. Now you have to put this in bracket in this way. Write this BY plus. And this you will raise this here. Multiplied A X minus, raise this Y. Right? If I say that By plus is the active mass of that, means what? Its active mass means its molar concentration, means its solubility, then KSP is equal to, what it will be? S raised to X. This is what it is. S raised to Y and S raised to X plus Y. So this is I say it is the solubility for this raised to X. Solubility for this raised to y, S x plus y. So this is the relation between this. Simply you can write this as x raised to x, y raised to y, because solubility it is. So KSP is equal to x raised to x, y raised to y, and S x plus y. So this is the relationship between solubility product and solubility. Let us take some example and understand this concept better. So the first example what you have. So we will see how to write this expression and what will be this calculation also. So let us take some of the examples now. So let us see some examples. The first example is AgCl. How you will split this? They all are sparingly soluble salts. So I will get first Ag, here it is 1, so it will be plus, and Cl minus. You can mention the physical states as aqueous. Below this I will write KSP. Below this I will write is equal to active mass of Ag plus and active mass of Cl minus. KSP is equal to, this is 1, so it will be 1 raised to 1. This is again 1, so it will be 1 raised to 1, S 1 plus 1. So KSP is equal to 1 raised to 1 is 1 into 1 raised to 1 is 1. So it will be simply S square. Right? Let us take few more examples. Like we have the second example, that is magnesium hydroxide. MgOH twice. How I will form this? This will give me Mg. See the opposite charge, 2 plus OH minus. This, there is 1 here, so I will mark 1. For this, it is 2 here, so I will mark this 2. Below this, I will write KSP. Below this, I will write is equal to Mg 2 plus and OH minus. Now, where to raise the powers? It will be 1, so it will be 1 here. This is 2, so it will be square. Next, KSP is equal to 1 raised to 1, 2 raised to 2, S 1 plus 2. So it will be 4S cube. So KSP is equal to 4S cube. Let us take the next example, that is calcium phosphate. Let us split the molecule first. You will get Ca and phosphate. Right? Now let us put the charges. Ca, opposite charge, 2 plus. So I will put here 2 plus. Phosphate, opposite charge, 3 plus. So I will put here 3 minus. Usually we write the cation first and then the anion. Now put the balancing here. This is 3, so I will write here 3. This is 2, so I will mention here 2. Next, KSP is equal to, KSP below this is equal to below this. What I will get? 3 raised to 3. 2 raised to 2. S 3 plus 2. So what I will get? KSP is equal to 3 raised to 3. 3, 3, 9 and 9 3 times is 27 into 4 and S 5. So you will get 108 S 5. So for this salt, KSP is equal to 108 S 5. Let us take one more example. You can do that simultaneously, students, to understand it better. Let us take aluminium hydroxide. Aluminium hydroxide, AlOH thrice. How I will split this? It will give me Al, it will give me OH. Right? Now, Al, how much? 3 plus. Plus OH minus. Let us balance now. Aluminium will be 1 and this will be 3. Below this I will write KSP. Below this I will write is equal to. Next will be what? Active mass of aluminium 3 plus. Active mass of OH minus thrice. KSP is equal to, this is complete analysis for the salt we are doing here. So I will get, here it is 1, 1 raised to 1, 3 raised to 3, S 1 plus 3. Next, KSP is equal to 3 raised to 3 is 27, S 4. So what is the relation? KSP is equal to 27, S 4. So I will give you one salt. You can try this salt here, that is barium sulfate. You can do this here simultaneously. Barium sulfate. How you will form here? Ba2 plus SO4 2 minus, right? Next, KSP is equal to concentration of Ba2 plus concentration of SO4 2 minus. Below this, KSP is equal to, what I will get here? 1 raised to 1, 1 raised to 1, S 1 plus 1. KSP is equal to 1 raised to 1 is 1, 1 raised to 1 is 1, so it will be S square. So for barium sulfate, KSP is equal to S square. So you might have seen that all the salts, the relation between KSP and S, they all are different, and so therefore it is very important that you should not make any mistake while establishing this relation, because the problems, they are based on this. Now what is the use of this solubility product? For this, solubility product plays a very important role in your qualitative analysis. Second application here, you can predict whether the particular precipitate will get formed or no. For that, I am writing the three expressions, and let us see what is the meaning of those three expressions. So the first is, when we see the concentration terms, we say that the solubility product and the solubility relation. So what should be the relation between them? So I am writing some of these particular equations here on the blackboard. So we have to predict. The first and the very important application is to predict the precipitation of salts. Now, I am taking a salt, say for example AB, and I am dissolving that in water. What I will get? I will get A and B. Now here, as it is 1:1, I can write here A plus and B minus. I am not taking the coefficients here. Now if I want to write the KSP, that is equal to active mass of A plus and active mass of B minus. Now if, let us take case 1. When I take this KSP and the active masses relation, we have to see A plus and B minus. Case 2, I will write all the three cases first, and then we will explain this. KSP is, I will write here A plus and B minus, A minus and B minus. Now, if I have written the three cases, what can be the three possible things what I can have? Let us see this. If the solubility product is more than the ionic product, then what will happen? The solution will be unsaturated. When the solution will be unsaturated, when the solubility product exceeds the ionic product, then the solution is unsaturated. When solubility product is less than the ionic product, or when the ionic product exceeds the solubility product, then the solution will form, or the precipitation will take place. Similarly, when the solubility product is equal to the ionic product, then we say that the solution is saturated. Very important to know this. I am repeating this. When the solubility product exceeds the ionic product, means when the solubility product becomes more than the ionic product, then the solution is unsaturated. When both are same, we say the solution is saturated. What is of our interest for qualitative analysis? Why a particular precipitate gets formed when you add a particular reagent? Because in that case, the ionic product exceeds the solubility product, and so you see the precipitate formation. So this is the application of solubility product in qualitative analysis. Thank you, students.